So in this video, we're going to take our concept of percent growth and decay that we learned in that last video with the basic formula and apply it to two formulas specifically related to interest. Interest being like how much money you're going to make when you put money into an account and invest it in something. The formula for this looks somewhat similar to our last one here. We still have a number outside parentheses, 1 plus or minus a rate going on here. The only difference here is this divided by n and this times n in the exponent here, where n refers to how many times a year your interest is compounded. When your interest is compounded, what that means is they take whatever interest you've made during that portion of the year and they roll it into your account. That is a good thing because when they roll the money into your account, that money will help you make even more money. So compounding your interest is good because it rolls in some extra money for you that will help you make even more. So I wrote down a formula here. I also gave you some common uses of compounded. When you might hear something is compounded quarterly, that means n equals 4, or daily, n equals 365. It's just how many times they're going to roll over the money into your account every year. So pause the video if you don't have this all written down, because it is kind of a lot for this slide, but doing the problems, though it may look complicated, it really isn't. Let's go ahead and try one out. So we are going to be depositing $37.50 into an account. $3,750 is our starting amount here, just like in the other formula, that goes outside the parentheses. It's always 1 plus for this, because it's assumed when you're dealing with money here, you're actually making money. And we're just going up by 1.25% interest. That's every year. As a decimal, that would be 0.0125. And our problem is compounded monthly. That is 12 times a year. So I'm going to divide by 12 here. All of that is going to be raised to the 12, again, n is in here and here, times 8 years. This setup looks maybe, I don't know, slightly complicated, but it's really not, and it's really just a matter of typing this into the calculator exactly like it looks. So I'm just punching this all in right now, just like it looks. I'll show you what my screen looks like after I'm done. Let's see, it won't all fit at once here, so I will show you what I've got here. I just typed in my starting amounts, 1 plus my percent, divide by 12, because I was 12 months here in a year. And then for my exponent here, I'm going to want 12 times 8, being sure, of course, that it's all up in the exponent. If you use an older calculator, you may need to put your exponent in parentheses. But I just typed in the problem like it looked, and there is my answer. Apparently, I will have $4,144, and I'm going to use 2 decimal spots because it's money. So we're looking at 4144 point. It'd be 18 for this cents on that one. Part 2 of this problem here says how much will I have made in interest? Well, I started out with this much money. I ended with this much money. So my interest is the difference between those. So if I subtract my two numbers here, so 0.18 minus 37.50, it appears that I am left with $394.18 in interest. So the hardest part is figuring out what goes where in the formula, and even that, after you've done 1 or 2 of them, isn't so bad. That is our compound interest formula. We have one more formula that is not as obvious to see where it came from. And at this point in your math careers, it wouldn't make complete sense to you guys yet, probably, just because of the math that goes behind it. But what we have here is a formula for continuously compounded interest. You will only use this formula if they say it is continuous interest. In this formula here, P, R, and T mean the same stuff as always. The only difference here is this lowercase e. E is actually an irrational number like pi, and it's a number that you'll use a lot if you go on to more advanced math classes. E is really important in advanced math. It's about equal to 2.718. It's always good, just like pi is about 3.14, to have an idea in your head of what it is. But on the calculator, there is a button for E. All you're going to do is hit second and the divide by key right here, and there it is. It's lowercase e. So doing the problems does not prove too bad here. You're investing $8,000 into an account. That's your starting amounts. And then we have E. Let's see, it's a 3%, so I still need to turn that into a decimal. I'm going to put 0.03 right there. Don't forget to turn it into a decimal. Times, and we actually don't know how much time. In this one I mixed it up. We're looking for the time right here. But we know we want our money to double. So we have 16,000 over here because that's double of 8,000. And what we're going to do right here, we don't have a good way to solve when we have a variable in the exponent. We haven't learned how to do that yet. That's going to be something we work on in this chapter. All I'm going to do here is take my 8,000s, and I'm just going to plug in different numbers for my time. So like, for example, I have my 8,000 times e to the 0.03 times, and I'm just going to try different numbers here until I get something that works. I went ahead and tried this one ahead of time, so I knew what the answer would be. If I try a 24, you can see right there that I'm at $16,435. But if I try a 23, I didn't quite make it to 16,000. So it turns out it's going to be between 23 and 24 years. Here's much money after 23 years. Here's how much after 24. So I would say for this one, between 23 and 24 years. And again, I use this formula only because it said the word continuously right here. That is the only situation where you'll use PE to the RT power.